All right. Hi, everyone. My name is Giuseppe Croce. I'm here with some of my teammates here, Scott Pepin and Briody. We're going to go through a unified software framework for automated testing. I've been with Raytheon for a little over 10 years. I've been doing software engineering architecture for, I'd say, pushing 20 years. I stopped counting after 15. Okay. All right. So kind of go through what our current state of development without having a unified software framework, right? So redundant development. When you're working with a large team, potentially coast to coast, not necessarily in one location even, you'll get redundant development. You have different teams kind of working on the same thing, reinventing the wheel over and over, right? If you don't have that unified software framework. Again, with larger teams, you're going to have inconsistent methodologies. Every engineer could have a different way to do the same thing. Steep learning curve, as you have larger teams, newer engineers coming on board. If you don't have that framework for them to learn from, if you have different methodologies again on different programs, you'll need more time for each one of those applications to come up to speed, to understand really what that code's doing. Integration, again, we're kind of building up here, right? So if you're reinventing the wheel over and over, you're going to have to reintegrate everything over and over. You're spending so much time really just duplicating all those efforts. And challenges with obsolescence. If you're not following any parts of your framework with the design patterns, trying to design for obsolescence, you could run into situations where you have so much hard-coded reused code, and then when you have to, when you have any instruments or something that become obsolete or that you have to replace them, you have to go through all your code, again, reintegrate it, redevelop, reintegrate it, and recompile everything. So it just adds so many challenges. So having a unified software framework, you're going to have a foundation to build all your applications on. You'll have reusable code. You'll have design patterns, potentially documentation, just process and everything for all your teams to really follow that. All right. So having that, right, the need, you'll reduce development time and cost. If you have your reusable components, standardized interfaces, common tools, you're removing that need to reinvent everything. Improves your test quality. You can, by having those best practices with your reusable components, with your processes and everything, you're going to improve all your test quality there. Some of the design patterns you can implement. Also, you could use, perform unit testing, right? Enhanced collaboration. By having those reusable libraries, again, we're really pushing a lot of that reusable code. You can have standardized data formats. You can have libraries that output those same data formats. And those pre-built reusable software components, right? We don't have to integrate them over and over if we've already done them once. You don't have to review all that code over and over if you've already done it once. Easier to maintain. You'll have a single source of truth for what your instruments or your test code is. It helps with your traceability and data analysis. Having standard tests, having not just your instrument libraries, having test libraries, just building on top of that, you'll be able to standardize all of those. I'll hand it over to Scott.
Can you hear me? Okay. Hi, my name is Scott Pepin. I've been with Raytheon for about 30 years now, and before that I actually worked for Lockheed 15 minutes away or 20 minutes, wherever it is, although it was General Dynamics when I started there. I started working with LabVIEW CVI version 3 when I was at Lockheed, worked with testing from the beginning, and over the course of the years, we've done the best we could up in the Northeast, which is where I'm from. I'm up from Tewksbury, Andover, Massachusetts, to try and standardize on common software and things like that. But, it's been, a challenge. So That's why we thought it was worth kind of bringing this to light and give you some insights into what we found, because we've been having a concerted effort to not only within the Northeast, but across all our locations to kind of standardize for a number of reasons. Like Giuseppe mentioned, some of it is the turnover rate, which I think everybody is probably experiencing. So it's very important that we can bring people in, get them up to speed right away. Plus we lose people, things like that. So some of the key components of the software framework, and I'm probably telling you something a lot of you already know, but it's worth going through them, is an abstraction layer. That's a key piece, hardware abstraction layer. And that'll provide a consistent interface to control, interact with all the instruments. And the key with all of this is, flexibility, modularity, extensibility, those kind of things. But it's all about shielding the TPS software from, the specifics of the hardware. The hardware abstraction layer is a key piece of that. You need something, test sequence and control engine, manage the execution and flow of test programs, give a nod to NI test stand. To me, it's the only way to go along those lines. And then data management and reporting, you need something to handle the collection, storage, presentation of the test data. And as Giuseppe mentioned, reusable test libraries. I'll go into that a little bit more. It's not just about the hardware abstraction layer. It's all the other routines that you need to glue all those pieces together. We try and provide everything the TPS developer needs to develop the TPS and minimize the amount that he has to actually go into the source code and rebuild it. And we try and bring that up to as high a level to them as possible, to make it that much easier and have a uniform way of interacting with, whether it be, those code libraries or, the instruments or whatever. So standard API kind of goes along the line with the abstraction layer. So well-defined interface that allows all the software framework to work together, including could be, interacting with external systems like manufacturing execution systems. We actually have a software basically that wraps around test stand that comes out of McKinney. Jason over here developed it, that shields the TPS software from, the execution environment, whether it's going through thermal cycling, vibrations, and things like that. So that's even another layer that we provided as part of our framework. I really don't go into that here, but and then a UI framework, so an operator interface. We even go further. We try to take a lot of these code modules that I'm talking about, especially the instrument control, and actually put a graphic interface on them, make them look like the instruments, soft front panels. Again, a nod to NI. They're doing some of that with their Instant Studio and Instant Studio Pro, if you've seen that at all. So that's something to look at if you're interested in that kind of thing. And then, simulation data logging. You're not always going to have the hardware available there. So you want to be able to simulate it if you can. That's going to work out a lot of the bugs before you get on the station, especially if it's a production station and, that time is valuable. And then, a data logging is key, of logging all the events, not just the Skippy commands that go back and forth, but if you have a manufacturing execution system, if there's robotic handling, all the stages of that, logging it so that you can recreate if something goes wrong, along the way. So in implementing the framework, here's some of the, decisions that you need to make. So the first one is, the technology selection. That's the programming language you're going to use. What kind of tools, protocols that align. That's going to be, in a big part, could be dependent on what legacy code you have, what experience you have within your organization. Are you a LabVIEW house? Are you more familiar with, Python development? Or, we're pretty much Lab Windows CBI, test stand. We use LabVIEW for real-time FPGA stuff. We are actually starting to migrate over towards .NET framework as well, more so going forward. But that's a decision you want to make, and again, try and push that across your whole organization with coding guidelines and things like that. So you want a robust, scalable architecture that, like you said, deals with obsolescence, future growth, and evolving test needs. Documentation, standardization, that's key. It helps to minimize the learning curve, have established coding standards. And a key one is common data formats, because we We have a number of different levels of test up in Andover. So we have design verification testing where they use full LabVIEW applications where they've created a LabVIEW state machine. They create CSV files with it. Our developers like to use MATLAB or Python, and they save their stuff in CSVs. We standardize actually on an older IEEE format called PDL, Parametric Data Exchange Language, because we have some legacy systems that use that. Moving forward, we're trying to standardize on a common format, feeding into System Link. That kind of gives you a leg up right off the bat of getting in a consistent format that you can use to do analysis. But being able to have that traceability from design verification through limited production, full rate production, and then even beyond, and be able to tie that across just opens the doors to so many other opportunities for doing machine learning or things to look for trends across the product life cycle and things like that. So having a consistent data format is key. Training and adoption, and it's not going to happen overnight, and we're still not there. We've done a lot more in the last few years. I have to say, for the first 20 or so years I worked with Raytheon, the amount of times that we worked with the other facilities, Tucson, McKinney, I can count on one hand, but there's been a concerted effort with a lot of the restructuring now across the test organization, and we've gone a long way to trying to standardize on a lot of these things. That way we can help each other labor-wise. We can, we don't typically wouldn't know the systems they use down in Tucson, but if we have a common framework, we can help them when they need help, or vice versa. That helps with our, manpower problems and things like that. And there's a lot of other advantages, obviously, to that. And the other thing is whatever technology, you're going to have to potentially integrate it into existing systems without breaking them, right? So you have to take that into consideration as well. And again, here's, across the product life cycle. So with design validation, if you give them these kind of tools, typically they would just recall instrument states, or they would, manually press buttons. It would help them, with rapid prototyping of new designs, and they can use the same test methodologies that we use for performing a certain type of test, whether it's a gain compression or a IP3, or I'm an RF guy, so I'm going to talk along those terms, but those can be done different ways and things like that, but you want a consistent approach so that you're going to get the same results across, the different benches. Otherwise, who's right, who's wrong, things like that. So, we're trying to push that down to them. Of course, they're resistant to that, and that's what's going to happen. They like to do things the way they do it. Who's going to pay for that, and all that kind of stuff. But, you have to sell the case of, the return on that investment that you're making. And it is an investment, right? So, characterization and qualification. So, they'll do a lot of characterizing of the devices in addition to just, testing them for pass or fail. They want to see how they perform. And then when you get to manufacturing test, field support, having that continuity of test methodologies, common data, analytics, dashboards, and things like that, you can get a consistent flow and know that as you're moving through the product life cycle that nothing is being missed or compromised, So that's some of the things. And then, a big part of it for us especially is we have test stations that are out there for 20 years plus, obsolescence, updates, things like that. So that's where having that hardware abstraction layer, a good solid one, to allow you to plug in new instruments, replace existing instruments, as well as go across from one platform to another. It makes that transition, because our goal is to try and, write the TPS up at that level and not have to touch it again, because those requirements typically aren't changing. It's what's underneath it a lot of times that's changing. So that's where we want to focus on, being able to have that kind of flexibility to be able to move across different, environments like that. Again, there's an initial investment to it that, we typically have had to absorb it over the years across different programs, and we don't just get a bucket of money for capital to go do this. So we'll have to build this up, and so it takes us time to get there. So we're trying to work through this, and again, resistance to change. And then one of the things that we struggle with a little bit too when we try and create these modular, reusable libraries. We try and put a lot of functionality into the instrument to handle the 90% use cases, but there's always that additional parameter or that additional function that somebody needs. So how do we bring that into the picture? Do we update it and deprecate the old one, or do we just create another library to add those, additional capabilities? So you want to strike the right balance to give enough capabilities, but have the flexibility and not compromise, the granularity of control that you're giving, the developers and things like that. And then maintenance, when you do updates, how you're going to roll out, updates. We're trying to use the package manager now to do our deployments, and we're, making good progress with that. But how do you roll those out to the station? If it's test stand, you might be running different versions of test stand, so you may have to activate different versions of the sequence engine, or you may even have to use like test stand environments to control which code base it's running at a time. Or we've tried using virtual drives as another, method of doing that as well. So, how you're going to roll out updates and things like that. So those are some of the challenges to it. And this is just some suggestions, I guess. So up to this point, a lot of it's been like motherhood and apple pie and all that stuff. And it's a lot common sense, right? And if that's a term anymore, I don't know if people say that. I'm showing how old I am, I guess. So we try and standardize for at least our instrument control on the IV specification. It's been around for a long time, but it's for lack of anything else, it's a good starting point, right? So it defines a lot of the core functionality you're gonna have. Unfortunately, it doesn't support all the instruments. We use the network analyzer heavily, phase noise measurement systems. So when that happens, then we have to come up with our own standards. So I looked at what Keysight had, I looked at what Enritsu and Roden Schwartz and tried to find the right balance and come up with our own in those cases. But overall, for the majority of the base instrument classes, it's a good starting point. And if you've worked with the IV shared components, we're working now in the Visual Studio and the C# environment. They give you all the interfaces that you can just implement. It gives you the code, skeleton, and then you just kind of pour in, all the commands and things from there. So it gives you a good starting point. If you're not aware, Lab Windows has an IV driver creation tool where you can create, again, the main classes, scope, switch, all the ones that are supported by the IV specification. And then LabVIEW does come with the class drivers for, the IV specification. But what we found, and I'm sure if you tried using them at all, the vendor-supplied IV drive is very much hit or miss. What we also find with them is, we like to have it be Skippy control in almost all cases. Some of them are COM drivers, which we don't prefer. And then the other thing is it doesn't always have the level of data logging and hooking into, for simulation modes and things like that we might want to use. So we make the investment of, we write all our drivers from scratch based on the IV specifications. We don't necessarily use the IV framework though, or the configuration store. We just use IV as a kind of an interface specification. And like I said, for lack of another standard, that's kind of a good starting point. And then what we also do is, in addition to the instrument drivers, we make sure, like I said, we try and give the TPS developer all the code that he needs up at the test stand level. So when I say up at the test stand level, we actually use test stand custom step types, if you're not familiar with them. So they look, for all intents and purposes, just like the step types, the pass, fail, or test, multiple numerical limit, and things like that come with test stand. But you put the code behind it, you put the parameters there that it takes and things like that, and they show right up on the insert menu. So it's right there in the operator's face. He doesn't have to go searching through, code libraries to try and find what he wants. You can categorize it in the menu for file directory operations. I mean, that's what it looks like in our menu, common math and analysis. So we give them, curve fitting, signal processing, array operations, things like that. Dialog boxes that they might have to put up, simple. Test stand has one, but, we try and give them a lot of different options, X, Y, progress bar, Maybe you might have to have a real-time, adjustment. So we have one that will support that kind of thing. Again, I kind of skipped the first one. We have the ability right from test stand to read and write to a lot of the common data formats, JSON, XML, INI files. We use those a lot of times for inputs, for reading and calibration parameters, or for us, it would be maybe classified frequencies or things like that, because we try and do our development, if we can, unclassified, and then just read those in at runtime. So we provide libraries for the operators to read those in. TDMS would be, we can use it as an input, but that's a data format that we might generate. You might want to use HDF files or some other format that might work better for you, or your data and analytics tools after that. And then we also even bring out communication protocols like RS-232, 422, Modbus, Ethernet IP. If you just need to do a straight VISA read-write to some instrument and it's not worth putting a whole instrument driver together for it, you can do that right from test stand. We have the ability to do TCP, UDC communications and all that. And these are all custom steps that we bring right up to the operator. And again, you can see the kind of the trend is, we're trying to keep from the operator having to go down and compile code that could potentially cause errors or issues and things like that. We have those pre-compiled, integrated, have the correct error handling and all that stuff up front. And it just goes a long way, especially with the learning curve like I talked about. It's just a matter, if you know how to use test stand, you drop these in and you're off and running. You can typically have somebody within a few days, if they know how the instruments work with our framework, they're up and running with it. That's kind of what we're after. Because I don't know about you, but our workforce right now is, I don't know, what's the percentage of people that are under 5 years now? It's crazy, So yeah, you have a question? Go ahead.
So I'm just curious, do you?
Oh, I got to turn this off. Hold on. You were supposed to yell at me to turn that off. So. Yeah.
Oh, so my question is, do you build the sequences manually in the test stand, or you have like a sequence builder, you generate the sequence files, and that's how you execute your sequences? Do you have like a custom sequence builder to build the sequence files?
Yeah. So the answer is no, but that's what this lends itself to, right? And that's kind of what we're gonna, kind of in the wrap up, we're gonna say that. So we're like everybody else. We're looking at, model-based approaches, maybe using ATML as well as, because they've had the CBI ATML sequence generator for a long time now. But do I want to generate, what level do I want to generate that code at? Do I want to generate it at the level of calling an instrument driver, or now I have all these high-level constructs that now I can use and piece together, whether it be instrument control or full measurement implementations and things like that. So it makes, I think, the code generation a lot easier at a much higher level than what you would have to do otherwise. So we're not doing that now, but that's something that we would like to do, And it makes sense, right? I think it, especially, and again, I'm gonna tip my hat in the sense that test stand, the API, you can do anything with it, right? You can use it to analyze, as you saw in the last session, but you can also use it to build your sequences and all that stuff. So it's very powerful. There's nothing I've seen that's quite like it. People complain that it's too complicated, but it's as complicated or as simple as you want to make it, right? So here's a couple of other things that we found through, so one of the things that's going to be definitely different as you go across the product life cycle is when you're on a bench, you may have no switching there at all. It might just be manual hookups. Then you might get into some limited rate where you have some simple switching. Then you get into full rate production in your production station. You have a full up switch matrix now. So how do you isolate that, from your TPS? So, we try and capture the switch path for each unique one in a station. In a file, again, down there, JSON, YAML, XML, INI, whatever your favorite flavor is, or a database if that's what you like to work with as well, and define all the switch paths down there. By the switches, refer to them by name, and then refer to the switch path, and then in your code just call set this path, right? Now, if you're not familiar with it, NI has their switch executive, right? So test stand, when you install the switch executive, the test stand steps in their pre and their post step, you have the option to switch and then say disconnect at the end of it. So it's built right into test stand. If you want to do that, you can graphically create your switch routes and groups and things like that. It is somewhat, I mean, you either have to have IB, I think IB switches, or it's tailored more with NI switches, and if that's what you use, then that's great. We don't use it. We build our own, abstraction for switching like that, because we use a lot of third-party RF switches that have higher power handling and things like that. So take it or leave it if that's something that might work for you. And another one that we found that's difficult to abstract is digital control, right? So there's so many different digital protocols that you might have. And so what we've found works is in our framework, we want to have, we call it a DUT property. It's and it's something on the device under test that you have to set. And in the example here, I talk about on a RF-TR module again. RF is what we pretty much do, or at least I do, at least up in the Northeast. You might have properties named, phase and attenuation, and then you would have, might be could be with some sort of a lookup table or a hash table or something like that, that would then take that and then, it would basically reference that into some function that you could load in and link in at runtime, and have like a plug-in architecture similar to what you would have in the hardware abstraction layer, but be able to plug in your digital protocols like that. And it could be, I've done it with LabVIEW, with CVI, with .NET assemblies. You can link those in, and then I can go from a Flex Rio to a high-speed DIO, pattern drive, whatever. So you can switch the technologies. It could even be high-speed serial instruments. It doesn't matter. It's up to you how you decide to abstract that. But again, it's all about, at the high level on TPS, that you need to go set something on the DUT. So let's just call it a property name and set it, and then handle that in your framework. And it makes the transition across platforms and hardware. And it's digital a lot of times is turns over a lot. With new FPGAs, they're always coming out with new versions and things. So that's something we find that we're struggling with a lot of times, is replacing it with equivalent technologies without totally having to rewrite the TPS and things like that. So, okay, so I'm going to turn this back over to Giuseppe at this point.
All right. So on our journey, to create our framework and evolving on it, right? Some of the things we're considering also are potential uses of microservices. We're trying to, create something that can be easily reusable, very modular, right? Breaking down what our monolithic HAL would be, rather than having a giant deployable executable or service or something. We're trying to break it up into smaller pieces. It's easier to deploy one of the smaller pieces versus redeploying everything, right? And then if you have to reintegrate everything, retest everything, breaking it up into smaller testable chunks is a lot more maintainable and just easier overall. You could definitely scale it. It's if you have one to multiple power supplies or any other type of instrument, right? It's much easier to scale the service through that way. Technology diversity. You could have microservices either in 32 or 64-bit, different programming languages. In the end, when you're deploying that microservice, you're just communicating to that endpoint. And on top of that, you can have different protocols too that you communicate to that, right? But you can still abstract all of that away. Fault isolation, right? If you have a single microservice that fails or having an issue with it, you can, it wouldn't impact the functionality of everything else as they're all running in their own container. And did I miss that bullet point? I think it's on the next slide. I'll wait for that. So as I mentioned, it's easier to update and maintain that as you're kind of working just as a smaller testable unit. And segregating HAL development. You can have different teams that are working on these pieces versus a single team trying to work on an entire library of everything. You can that same team can also test it, manage it themselves. It's just easier to do that. And implementing it. So ASP.NET Core, .NET Core, the latest versions of .NET, they're now cross-platform, so you can run that on Windows, Linux, Mac OS. That's kind of, as Scott, I believe, mentioned, that's one of the languages we're standardizing on. Going forward, we're trying to do more C# and .NET. So this is something that we're trying to target as well. Provides ASP.NET itself provides a great framework for building the REST API, that backend API or web UIs on top of that. You can host it on IIS, deploying it in as a Docker container. That absolutely helps when you're trying to, release different versions, just even configuration management of that container and how, you would interface with it. I did touch on that a little bit with the RESTful APIs. You can use RPC or even gRPC. With that container or that microservice, you can have a front end on top of that too. So Blazor is one of the ones that Microsoft provides that you can build a UI for your instruments, your test methods, any type of front end you want to have to it. Maybe even some sort of logging dashboard or some view into whatever errors that your microservices are encountering. And NI's Instrument Studio Pro, you can use these microservices with that as well. And there's we did cite some examples there using ASP.NET and gRPC. NI has a device repository that has all the gRPC protobufs. So that's definitely great to reuse, build a framework on top of that. And there's also a gRPC test stand API. And again, Scott had mentioned this, we're using teststand as our sequence engine. There's no question really to that, right? Why wouldn't we want to standardize on this? It already provides so many capabilities that we're trying to evolve our framework to. It works with .NET, Python, the built-in gRPC libraries. It has the standard test data exports, publishes straight to system link. So many capabilities that it provides that we don't have to build anything custom for, but also provides us the extensibility to use the custom set types that we're working with too. All right. So any questions?
And to be honest, we would have liked to share a lot more with you, but Raytheon wouldn't let us, so we have to walk a fine line of what we can bring to these conferences. So
I just had a question for the instrument driver development and abstraction. So you were mentioning that you're referring to the IVI specs document to develop the instrument driver. So my question is, are you just considering identifying the interfaces that's mentioned in the specification and developing your functions using the Skippy commands?
yes.
Okay.
Yep. I mean, to be honest, they're dated, right? So if you look at, a DMM, or you look at, they don't have some of the capabilities that a lot of the modern instruments have. So you have to choose how you want to, extend that. If it's a common feature that everything has nowadays, maybe you build it in, or, maybe you just create extension methods for if you're doing a class or something in C#, or you just have to figure out how you have to extend that, or do you just, have the core one that has all the basic functionality and create yourself a separate one that's instrument specific? It's, there's a number of ways you could implement that, and you have to decide what works best for you.
Yes, I think we started the approach recently, and we are developing the same.
That's always a challenge. There's a lot of, like I said, it's a good starting point, right? I mean, it is a standard, and it's a good starting point, but they really could use an update, so, yeah.
Thank you.
So when you're building and maintaining a unified framework like this, how large is the team that you have that's building and maintaining that versus how many people are using this, and how do you define that value proposition to your manager?
In the Northeast, it's right here. So, yeah, no, that's a challenge. It is an ongoing effort to develop and maintain it as new instruments come along. We will bring in people to do some of the lower level instrument driver development, but Chris and I typically are the ones that will tie it into the overall test and software framework. So it's really just a couple of us that maintain it, to be honest. Yeah.
And I imagine this is used by a lot of people.
Yeah.
Okay.
Yeah.
And one of the challenges we've encountered, right, as the team's been growing, initially we had our own little domain, I guess, within, Andover or in Tucson or McKinney. But as we've grown our team, now we're trying to establish this framework to support all the sites.
Yeah. And to be honest, this, I'll call it paradigm that we use for development like that, because like I said, it's custom step types they actually have graphical panels for them. Right now they're in process, they're built. You can right click, edit input parameters on the step, bring it up, fill it out, and it just makes it a lot easier for someone coming up to speed. That approach we've used for a couple of decades now. We had a very complex instrument before this that was a microwave synthetic instrument that was very difficult to tame and use. So that it came out of necessity with that product, but we extended it even then to all the COTS equipment as well, just so you have a common method for controlling all the instruments, whether it happened to be that synthetic instrument or a power supply or something. And now we've just taken that into the next, onto the next level now with our current RF platform. And yeah, so it's worked very well for us. Again, there is quite an investment, so it's not something you're going to be able to do overnight. Whenever I showed in the past, that was always the question: is how long did it take you guys to do that? And it is an investment, but I feel like it's worth it afterwards. You do get the payoff, but you just got to figure out how to do that up front and get that funded or whatever your case is, right?
So with so many of these reuse blocks maybe being black boxes, right, to the end developers, how do you bridge that gap from when they encounter issues and maybe need debugging that they don't have, necessarily the insights to what's going on under the hood, to know if it's, the block side or how they're trying to use it?
Yeah.
How have you brought on the developers to kind of peel back the onion and get into that?
Yeah. I mean, don't get me wrong. Our developers it's not that they don't know how the code underneath it works. We're just trying to avoid them having to go into that. And there are some that don't like that, obviously, because they want to be part of that, and it feels like they're stifling their creativity. That's a challenge as well. But there are some that have been doing this for many years, and they've had enough of that, and they're happy to do it that way. But, we encourage them to, to step in and try and figure it out, use our NIIO trace monitor. But that's also where if you do enough data logging and things like that, and you can kind of see where the error happened and try, to try and recreate it. So yeah, it's no magic bullet, but yeah. So we don't prohibit them from doing that. And we made it a tool for them to use. If it doesn't work for them, we want them to justify why they're not going to use it, because we put that in place for a reason. And the point is anybody should be able to step up to that station with that software and be able to use it, and that's what we're going for. We don't need to have somebody that's specialized in this station or this one, the software specific to those, which is what we still run into in some cases. And don't get me wrong, it's not roses, and we haven't figured it all out. It's still an ongoing work in progress, and will continue to be, right? So it's a constant struggle.
It's one of the key things you want to consider when building out a framework is you have enough logging to provide all that information. I mean, yeah, you definitely could go through the code and start stepping through it, but you need to have a good place to start. So defining that pattern of how you're going to log stuff is pretty important.
How often do people need to make like these custom sequences?
The custom steps?
Yeah.
maybe with a new station that has new instruments, that's where we'd have to, and it's not even a custom step in those cases, unless it's a new instrument class. It's just a low-level driver that we plug in. The way with CVI, we use basically Windows load library, unload library. We use function pointers to resolve it. You might do it in C# with, maybe the activator class or something, and, to create dynamic, instances of objects and things like that. But I won't say it's that often. I mean, we've developed enough of a library of functions, and we have support for all the instruments that are in the station there. So, it does come up though. It seems like somebody needs this feature that we didn't add, that we didn't think anybody would need, or things like that. So we do have to figure out how to add those in. But yeah, it's not too bad. Once you build up the library, it's really, and it's nice. I mean, like I said, you can work almost completely in the testing environment. You have everything, all the things you need to. It's very powerful.
I'm being asked to, I'm the old man at the shop LabVIEW guy, and it all comes down to me. I'm trying to bring up a bunch of people who have no experience. So I've been creating sub VIs, but they're still in there and having to write the over, and it's still a ton of work for me to keep them going. But right. Kind of blowing my mind a little bit, creating this next level of abstraction.
I mean, some people don't like that. Some people prefer to work and do it the other way. There's others that want to do the entire test down in the code. To me, I want integrated, everything, code modules that I can just call from that level and sequence. And like I said, it makes the code generation, if you want to go to that level, it just, so you have multiple levels of abstraction. I mean, the custom step type is a level of abstraction, right? And then you have your hardware abstraction layer itself, right? And so it really isolates the TPS from any of the hardware specifics, really in a good way. And so, yeah.
Right. Yeah, and I'm in medical, so I'm trying to figure out at what layers I can do validations of some of these abstractions, and then sort of keep people out of the guts of it and touching it and those type of things. So yeah, it's fantastic work. I'd love to. I know you can't share much, but love to see more.
Yeah. No, No, I'm glad you got something out of it. I wasn't sure how this would go over. I thought it was an important thing, and to talk about some of the challenges that we had, and the approaches that we've taken with it. So hopefully you come away with something at least that might help you. So,
can you talk to me a little bit more about the documentation and how they find what libraries are available to them to use?
Yeah, we have a wiki that we've developed where we show the step types. We have we'll have the diagrams in there, and I mean, again, unfortunately it's the last thing that gets done, right? And we still have a long way to go with that. But to be honest with you, I wish I could show you the framework itself. But to be honest with you, it's so intuitive to use. If you know how the instrument works, you're going to know how to use the framework, so that's not an excuse for documenting it. Of course, that should be done, and Chris has done, quite a bit with those along those lines, and we've had user group meetings on our station where we've gone through that training and things like that. So I don't know.
And do you guys kind of have like a change control board for when somebody requests a new feature and things like that?
Yeah, it's kind of simplistic. I mean, we use Git to keep track of any issues people find or requests that they make, and then whenever we do the update, they'll get an email saying that we made this change, this whatever, to the repository, or we added this capability or something, so. Yeah.
We do in Tucson, I think more so, we try to have architecture documented, at least in some model-based engineering tools. So we'll have some of those diagrams, class diagrams, sequence diagrams to show some of the behavioral aspects of it. But
yeah, they've gone a lot further with, the modeling aspect of it, and they use that for a lot of their documentation. Is it fair to say that? Or
yeah.
Yeah.
Are you able to generate any LabVIEW from your models?
So they don't really
Not
use
LabVIEW?
LabVIEW. C Sharp. C Sharp. But I mean, it could be LabVIEW. I mean, it's in this case C Sharp, but yeah. Yeah. Did you have a question?
Yeah. Do you have a triage process for bugs or feature requests?
As far as what?
As far as developers that are using your tools and your framework?
Yeah, they send Chris an email and tell him something's not working. That's about, and he's already got a couple while he was here, so that goes to show you how good it is.
Okay, I guess that leads into the next thing, which is how do you keep yourself from being pulled into every developer's problems and investigations?
We don't. We are involved with a lot of them.
Learn to delegate and say no, which I haven't figured that one out.
Yeah.
So for your test stand development, are you using C# and are you using test stand API for that?
So that's what we're moving towards, right? So we're like you talked about, we're moving more towards the microservice architecture, C# modules, gRPC. And as you know, gRPC lets you use C#. It could be Python, could be whatever on the other end of it. We're standardizing also on C# with the ASP.NET Core. If you work with that at all, it's a very good way of creating microservices. And then you have the communication interface with test stand, but also we can have a GUI on the side as well that, so that same microservice can have multiple ways of controlling it. So operators on a bench setup could use it that way. We can use it automated from test stand. So that's why we like that architecture. Plus we're switching from a 32-bit, we've always done 32-bit, we're going to 64-bit test stand. And of course everything has to be, but if you were going through a gRPC service, it's out of process and you can do whatever you want now. So you have that independence that you didn't have before, so.
But I have a question on that.
Yeah.
Since if we want to use Blazor or gRPC, we have to move to
.NET 8.
Yes.
But most of the instrument drivers currently, they suggest to use .NET Framework.
Yeah.
So do you foresee any concern on that?
You can use the interfaces that the Ivy shared components provide with .NET 8. I've done that and developed. And same thing with Visa. I've used it with both of them. But yeah, that was a concern of going from 6, because even the Ivy shared components are kind of behind with that, right?
Right.
But it does work. I think it's what do you call it when it can be compiled for a number of different frameworks or versions. They support that. So the other way around was a challenge before when it was 2019, say test stand, that didn't support .NET 8. You were stuck in .NET 6, and you really couldn't use the gRPC with that. So now that they've gone to .NET 8, it opens the door for that. Yeah. But that is a concern, yeah.
So you recompile all your existing driver to .NET 8. That's how
you can, yeah.
Okay,
Yeah.
that's something provided by Visual Studio or something?
Visual Studio.
Okay.
Yeah, that's what we use, yeah.
Multi-target.
Multi-targeting. Yeah, that's what it is.
Thank you.
Yeah.
But for the new driver, there should be no concern since we are building on .NET, we'll be compiling on .NET.
I haven't found any issues with it, yeah.
Okay. You guys still use like NI Visa or IVI, or you are going to use the IVI handle?
I use the IV Visa, so that way if we ever used anything other than NI, although we haven't, but it opens the door if you were using Keysight IO libraries or Roden Schwartz, Visa. By using the IV, it automatically selects whatever the active Visa session is, so it's kind of better to go that way with it. It is a little bit different, using it, the interface they found, but I think it provides you a little bit more flexibility to go among them if you needed to, so.
Awesome. Thank you very much. That was insightful.
Okay.
You touched on it earlier, but can you talk a little bit more about maybe more successful and less successful strategies to overcoming resistance to standardization? It's definitely something that I've seen, and kind of as the potential for use grows, you hear more and varied resistance to it. So what's worked well for you in that regard?
Have them call and go fight for us to, So we work for Giuseppe. Giuseppe works for Colin, and he fights those battles for us. So that's
Having good
kinda
leadership.
answering without answering it.
Yeah, I think it's having leadership engagement and being able to communicate the ROI to the business, right? Because having the engineers be able to do their job easier isn't a selling point for the company. So if we can turn around to show how we can do reuse and use the same thing instead of doing it 15 times for 15 different programs, that's been our major selling point.
Yeah, that makes sense. How have you shown the ROI? Is that kind of based on like previous programs versus current?
Essentially how we used to do things versus how we do things in the new way, and the amount of time it takes to write the code, and then how much time you don't have to spend on each of the following 9 iterations because you did it on the first one.
He must have missed your presentation, Jonathan, right? Isn't that what you
So, and then one more, maybe more technical question is, in your framework, have you considered or do you see opportunities for AI and AI generative applications? And what areas are you looking at for that?
Within the framework, I don't know. I guess I really hadn't considered that or where a use for that would be. We're kind of looking at more using it for the types of things I think that people like, maybe doing requirements analysis and generating, either ATML or SysML or whatever, and then using that to do sequence generation. That would be something we would focus on more. We have other efforts going on within Raytheon, and we would like to also look at it ourselves is, if you can look for failures of, say, something at a higher level and be able to look and get insights in to things that you might not see otherwise at lower level testing, right? That's always the thing, we always want to catch it as soon as we can. So there's efforts going on trying to, it might pass that test, but if it's modular on this one and it's that one on that, it's going to show up like that later on. And, we have more of a focus on, I think, those types of things that get us more of a direct, execution and, bang for a buck in that sense. I'd have to think about, you have any ideas of how you might use it in the framework?
There's still some discovery that we have to go through, understanding what the right questions are to ask and what that data is going to be. If we understand what that data is going to be that we want to capture and perform anything on, that's something that can be built into the framework so that we're always preserving that data for anything AI related.
You mentioned you're simulating. At what level are you simulating? Are you just generating like random numbers, like zeros back, or are you like literally playing back a previous set of data that you've already run through?
Yeah, it's not necessarily, it's hard for us a lot of times to play back the data because it's usually off of a classified system. And when we're simulated, we typically want to do that off of, our laptops and things like that up front. But we do, and that's another area that's kind of fallen behind, but something that we want to improve upon. But I envision being able to either have a TDMS file or a HDF, again, whatever is your format for storing scientific data like that efficiently. It could be JSON or INI, things like that, or have tools to generate, a polynomial or things like that, so that we want to build into our, our step types or into our, whether it be for, right before it does the analysis or right out of what the instrument would have created to substitute in and have different ways of generating more realistic simulated data. We don't, because just generating like random numbers like that doesn't really help you a lot of times, right? You want to be able to, so whether you read it out of a file or have something you can generate algorithmically, but that is an area that we could use improvement on, let's say. So,
how does your framework extend into test stand? Are you utilizing like plugins, or are you customizing your product or the models?
Yeah, we do have a custom process model, but it's really for the report generation aspect of it that we do, because like I said, we support text-based, but we also have PDEL, which is IEEE 1545, I think, or something. It's nothing that I would recommend using, but we have legacy tools that work off of that. But other than that, when you say plugins, we're using custom step types. So if you look at the examples that come with test stand, they do have some examples of custom step types, and you'll see what I'm talking about with those if you look that up. They look just like the standard types that when you go to the insert menu and you say insert and multiple, you can create your
with custom.
Yeah, you can create your own menu there, put your own steps in that call your own custom code modules. So it becomes, we have
I was referring to process model plugins.
Oh, process model, just for the report generation. And then obviously the system link one as well. Okay, we use the client for that.
Cool. And then, and so how do you deploy to your production systems?
In what sense?
So you develop code, but then do you have production systems that run code? Are they a full development environment, or is it like a deployment like test stand license?
We have a full development environment on there.
On all production systems?
If we send it to a depot or something like that where we don't want somebody messing with it like that, then we might do that. But we have enough control from a Windows security standpoint that we're comfortable deploying it, because it makes it that much more difficult when we have to go out there and make updates or look at issues. We want to have the full development environment there. So we do leave all the source code and everything on there for the most part.
Okay.
Yeah. But we have checksums that we run on all the important things, all the DLLs and things like that, so that we know what we're running is what we released and things like that. So we do extensive checking like that to make sure we're running exactly what we think we're running, So.
Thanks.
So what is the primary reason for you to shift to the microservice architecture? Is it because the ActiveX is getting depreciated, or you want to get the benefit of the new architecture?
It's really because, and I don't know who's left from NI here that can argue with this, CVI is being basically sunsetted, right?
Yes.
Yeah, that's it. That's the driver.
So the ActiveX has CVI? Because if we are using like the ActiveX with the current...
No, that's not ActiveX. That's Active Server components. It's a different thing. Doesn't use the ActiveX standard. It's just a framework for developing. It was used to develop like web. You can develop dynamic web applications with it, but it's a very popular for implementing microservices, because you can run it in. It's called Kestrel. It's a built-in web server that it can run on, or you can easily just say, I want to host that in a Docker container, and it'll generate a Docker container for you. So it's a very powerful way of creating microservices.
So this is in relation to test stand you're mentioning, right? So my question was, my understanding that currently the test stand uses ActiveX for all their UI.
Test stand, yeah.
Yes, they uses their ActiveX for the UI. However, Microsoft stopped the support and it's depreciated. So even now we are considering to move to gRPC. That's one of the primary reason.
Okay.
So since you guys mentioned you're also considering gRPC, is that the reason, since ActiveX is depreciated, that's why you're considering to the new?
No, I wasn't talking about for test stand itself. So that's kind of interesting. I mean, I think NI has to figure that out, right?
Right. I asked that question yesterday. So what they said to me is for the newer development, they suggested gRPC. But however, they also mentioned since...
for interacting with the test stand engine?
Right. Yeah, interacting with the test stand engine and their UI. So you have the interop assembly. Yeah. So you can still use that, and they are going to support it for at least, indefinite time, the ActiveX. But the concern is ActiveX is depreciated and they may not be a good cyber security. So we are considering those angle and thinking to move to gRPC.
Okay.
But however, test stand confirm, we still support ActiveX for future.
Well, you're telling me something that we didn't know, so that's good. Thank you. Goes both ways, I guess.
There's other reasons, though, for going to a microservice architecture, but it's also a challenge of how micro do you go, right? There's got to be a happy medium where you're not going to have a microservice for a single instrument, because then you could have, dozens of other services running, and that could be a nightmare itself. But yeah.
So talking about data and fault insertion, that kind of sparked an idea that as your reused code base kind of turns into its own product, what are you doing to as far as like verification and like continuous integration, continuous deployment of that project? Do you have like automation or tool sets that you're using to facilitate that?
They're a lot further along than we are with that, and so we're gonna, there's ongoing discussions with that as well, and maybe how we can integrate that into our workflow as well. So that's where, we all bring different things to the table, and we're trying to find the best approach for all of us, and we don't do that at all right now, at least up in the Northeast. Down in Tucson, that's something they've been doing for a while now and have a lot more experience with. So
how do you verify and build confidence that the reuse code is going to work correctly? It's kind of like the stakes go up the more applications you reuse it on, right? If it isn't correct.
Yeah.
So that's a challenge in itself, right? Ideally, perfect world, we're building all our code. We have unit tests and 100% test coverage, but we can only mock so much of it, right? And then trying to deploy it into an actual production environment and run integration tests on hardware, that's even harder to do, right? So we just try to build as much confidence on those lowest layers as possible, integrate that on some hardware, making sure that capability or functionality is solid, and then just build on top of that. But yeah, leveraging, CI/CD, unit tests, mocking, and any hardware we can get our hands on to test that.
Yeah, because a lot of times, unit tests is good, but some of the things that you're trying to test for, make sure it works across, relies on, say, the product, that specific type of signal it's generating, and it is challenging a lot of times to know when you go from one instrument to the next that you are getting, So I don't know. Unit testing alone, I don't think would do that. It's just a matter of running it and making sure we do extensive repeatability, correlation studies on anything before we deploy it, and make sure that it's all, if we switch instruments or whatever, do any software updates, we always have to make sure that nothing in the data has changed. It's still repeatable. It correlates with another station if it's running the same test program. So we go through all those activities every time we release something.
Definitely trust but verify.
Yeah.
Right. Thank you.
All right. Thank you, everybody. Appreciate it.